Hello guys, so today I'll be solving this problem. So I have already solved this problem, but I don't know, for some reason my streak count is not getting updated. Um, so yeah, if you guys are facing the same issue, please do comment in the chat. So yeah, not sure why this is happening. Okay, cool. Let's get back to the problem. So today's problem says that we need the count of unique three-letter palindromic subsequence in a string s. Okay, so we need the count of three um, character palindrome present in s. Okay, which is our given string. Okay, now those of you who are not familiar with palindrome, so palindrome is a string which is read the same if you read it from left to right, or you read it from right to left. So for example, let's say I have a string a b c b a. Okay, so if I read it from left to right, it is a b c b a, and if I read it from right to left, it is again a b c b a. So yeah, both are read the same. So yeah, now here we only need to find three character palindrome, which basically means the length of the palindrome is 3. Now what does that say? It basically means the first character of the palindrome and the last character of the palindrome are same. Okay, equal. Cool. Now if we go with couple of examples here, okay, let's say this guy a b c a. Okay, so in this thing I can observe, like, I can take this and this. I can generate aba. Okay, now I can take this and this. I can generate again aba. Okay, now another palindrome, three-letter palindrome I can generate is like using this and this a. Okay, which is a, and another palindrome I can generate is maybe this a, this, which is aca. Okay, the same can be generated using this a, c, and a. Yeah. Now the question is basically saying that we need the unique palindromic count. So even if multiple palindromes are occurring multiple number of times, I need the count of only unique palindrome. So here I will reject this aba. Okay, so total number of unique palindromes I'm getting, that is AAA, ABA, and ACA. So yeah, 3. And yeah, 3 is the answer. Cool. So how to solve this problem? Okay, so in order to solve this problem, we need to think in the direction of how palindromes are being created. Okay, so the palindrome structure is something like this and this. Okay, yeah, so the palindrome structure is something like this. So this two guy are same. Okay, so this guy will be changing. Okay, it may occur like this three character are same, which is in this case. Okay, so but yeah, the structure is something like this. Now this guy is changing. Now we can get an intuition something like this. So if I have a set of characters, okay, uh, that are given to me, okay, which is basically s. Okay, so let's say for c in s. Okay, so c is the, so basically I'm iterating over s. Okay, then if I can check, okay, um, so for every character in s, okay, if I can find some characters, okay, which are present on my left as well as they are present on my right, okay, then I can clearly say I can generate a palindrome with them. Okay, so yeah, uh, that's the idea behind it. Now we can see the constraint. It says that s only consists of lowercase English letters. So yeah, just a hint for you guys. So whenever whenever we are getting this kind of hint, so it's usually you can think of, so the questionnaire is kind of like uh, pushing you towards a time complexity which is of this manner. So 26 times some factor, okay, and this factor can be like n log n is like length of the string, or can be n, okay. So yeah, so why 26? So since the domain of all our characters is the set of alphabets, okay, and we know the set of let's make it a b c. So yeah, so we know the set of alphabets have only 26 character. So if we have this set of alphabet size as a multiplicative factor for our time complexity, or even with our space complexity, so we will only get a bump of 10, okay. So it will just increase our overall time complexity by 10x, so which is not that much, but yeah, in some cases it can be. But yeah, so but yeah, most of the question where we are given like this kind of a constraint, so you guys can think in the direction of some kind of how to use the 26 or the number of English letters or English alphabets in my time complexity or in my algorithm. So yeah, so this is something we will be using it here, okay. So for the middle character, I can iterate over all the character of s, okay. Now for each middle character, I can simply iterate over the set of all my alphabets, which is, let's say, c2 in the set of a to z, okay. Cool. So with this, I can create a palindrome, something like this. Palindrome will be c2 plus c plus c2. So yeah, now I just need to check whether I can build this palindrome or not. If I can build this palindrome, which basically means I will increase my ans by 1. So yeah. Now, how to check whether I can create this palindrome or not? So in order to check this, so we will have uh, we can use a concept here, okay. So for example, let's take this example again, okay, a b c a, okay. So let's take other maybe let's say I have an x and an a, okay. Cool. So here I can say, so uh, I will get a new palindrome, which is this xa a, and same palindrome as I was getting before, aba and aca, okay. Now, so if I check for every character, okay, so let's say I'm at this character, okay, which a is significant for me on the left, okay, clearly this guy, okay. Now let's say I'm at this character, okay, which a is significant for this character on the left. So this guy is there only, so yeah, this guy again. Now for this a, okay, which a is significant? It has two choices. It can go with this a or it can go with this a, okay. But if we look, this a is kind of to the leftmost, and it is kind of helping this two characters to create palindrome, and it can also help this guy to create palindrome, okay. So we can think whatever is the leftmost occurrence of a character, okay, that we can like that can be paired with other characters, okay, to generate palindrome, even if that character is present like at other indices. But if we consider the leftmost occurrence of that character, we can use that character to pair up with other characters on the right, okay. Cool. Now Cool. So similarly for B, so we have three choices, but yeah, I will pick this guy as my leftmost, like as per my leftmost analogy. Cool. Now again, let's take this. Let's take this example. A. Uh, so let's consider A X A. Okay. Cool. So now, we solved for the middle character. Okay. This is like the set of character in my S. Then we looked at my first character. So I'll be taking the first occurrence. Okay. Now what's the catch for this thing? Okay. I need to put the same character here, right? So which indices should I prefer? Okay. Now in this example, I can say, so if I have something like this, okay, so I need to take the leftmost character, right? Okay. Now in order to generate the palindrome, okay, so what all characters I can take? So can I take this character? No, because if I take this character, there are no character in between. Okay. So can I take this character as my last index? Or can I take this index as my last character? Yes. Okay. So because if I'm taking this character, so there are multiple characters in between them. Okay. So this will help me to bump the palindrome count. So yeah, that's the concept. So for every character, if we know their first occurrence and the last occurrence, okay, we can use those value to create palindromes. Okay. So I'll just go through an example. So maybe I can create another whiteboard. Let's dissociate this. Let's associate this. Okay, let's go with this. B, B, C, B, A, B, A. Cool. So the indices are 1, 2, 3, 4, 5, 6. Yep. Yeah, 7, 6. Cool. So let's have a data structure that can capture the first and the last occurrences. Okay. So first and last. Okay, and this is for C. Okay, let's go with A. A has its first occurrence at 4. Okay, and has its last occurrence at 6. Okay, now for B, B has its first occurrence as 0. Okay, and its last occurrence at 5. Okay, then for C, it has its first occurrence at 2. Okay, and that's its last occurrence also. Okay, cool. Now how to solve this? Okay, so we saw that for the middle character we will be iterating over all the characters in S. Okay, so I will iterate over B. Okay, then what I will be doing is, so I'll be using this for loop only, this for loop logic. Okay, so for C in S, okay, C will act as my middle character. Now for the peripherals, I will iterate over all the characters present in my alphabet set. So for C2 in set of my alphabet, A to Z maybe, or yeah, A to Z. Yeah, now I'll check so for C I know the index. Let's say I know the index of C. Okay, now I'll check for C2 if the first occurrence of C2, okay, is less than my I, okay, which is my current character index. Okay, and okay, the current character index is less than the last occurrence of C2. Okay, so can I safely say that I can generate a palindrome with it? Yes, I can. So if I see for this B, okay, so I will iterate over all the set of characters. So for A, okay, so the first occurrence is after this 0, so I will not take this. Okay, so this loop will not validate. For this B, I'll get this. Okay, I'll get this b. Okay, because its first occurrence is less than this index. Okay, now if I check the last occurrence, so the last occurrence is 5, which is more than 1. Okay, so I can use this b, okay, to pair up with this b to create a palindrome. This is what I will be doing here. Okay, so yeah, I will update my answer by +1. Okay, so yeah, cool. Now when I'm at this index, okay, I'll check. Okay, so do I have any character whose first index is less than this? Yes, I have b. Okay, now do I so is the same b having a last character or last occurrence greater than this current index? Yes, it has. So yeah, I will update my answer by 1. So I can say +1 here and a +1 here. Okay, cool. So right now I have created like bb, okay, and bcb. Okay, cool. Then again, so for this b, okay, so do we have any character whose first occurrence is less than this? Yes, I have. So now let's check for the last occurrence. So yeah, this b also works here. So b, b, b. Okay, now the thing is this b, b, b. Okay, I have already like used this to update my answer. Okay, so this is not a unique occurrence. Okay, so I will not update my answer at this stage. I'm getting a unique palindrome, but this palindrome I have already used to update my answer. So here I will not be updating my answer. Good. Then in my next iteration, okay, I have an a. Now I'll check whether I have any character, okay, whose first occurrence is less than a, like less than 4. Yes, I have this b. Okay, now is the same character's last occurrence, okay, is greater than this index? Yes. So now I'm getting a palindrome of BAB, okay, which I haven't found yet. So I will update my answer by +1. Cool. Then I have this b. Okay, now I'll check. Do I have any characters whose first occurrence is less than 5? Yes, I have. I have b, like I have a and c. Okay, let's go with a. So for a it's 4. Now for the same a, the last occurrence is 6, which is more than 5, which means I can create a palindrome of ABA. So this is a unique palindrome because I haven't encountered it yet. So I'll do a +1 here. Cool. Now let's check for C. So the first occurrence is less than 5, which is good. Now let's check for the last occurrence. Okay, so the last occurrence is 2, which is less than 5. It is not more. So which means I cannot create a palindrome of CBA. Okay, so yeah, this guy didn't contribute to palindrome creation. Now for the last character, do I have any character whose first occurrence is less than 6? Yup, I have multiple candidates. Now I will check whether their last occurrence is more than 6. So for this guy, nope, this is not more. Okay, for B, nope, this is not more. Now for C, nope, this is not more. So cool. So in the end, I'm getting 4 palindromes. Okay, so if I add them up, so I'm getting 4 palindrome, which is like the answer here. So yeah, the logic is, so consider all the characters in S as my middle character in my palindrome. Okay, now just try to check, and for the peripheral characters, take the set of your alphabet. Okay, then have this first and the last occurrence to check whether you can create a palindrome with that or not. If you can, bump your answer, but before bumping your answer, check if you have visited this palindrome or not. Okay, now how to do that visited? So you can like concatenate the characters, okay, and have a set of maybe a set of string to keep on like pushing those strings in your data structure, and finally you can return a unique count of that. You can do that. Okay, but if you see, so how many palindromes can we get in total? Okay, so I have 3 choices for the character, right? So whatever character I'm putting it here, okay, those I will be putting it here. Okay, so 26 characters I can put here, and the same 26 I'll be putting it here. Okay, now how many characters can I put it here? Okay, so it may happen the string s have all the set of alphabets, okay, like all the characters of alphabet, which means I can get 26 unique characters here. Okay, so in total if I see, okay, I'll get 26 times 26 palindromes at max. Okay, which is I think 576. Yeah, let me check. Is 676 or 576? Yeah, 676. Oh, I forgot. Yeah, I think I closed the tab. Okay, but yeah, as per the visited logic, okay, so at max, so I can use a set of string, okay, but the total number of palindromes I can generate is 26 times 26, which is 676. Okay, so I just need um, this level of space complexity, so I can do a trick here. Okay, so if I create a data structure something like this, I'll say an array of array. Okay, and let's say this is of size 26 cross 26. Okay, and if I treat the first like the rows as my middle character, okay, and if I choose the peripherals as my columns, okay, let's say peripherals. Okay, so I can use this data structure for my visited. So I think it's better if I show you in the code, but yeah, so instead of using a set, okay, which will give you logarithm complexity, okay, I can use this data structure to get a constant lookup time. So yeah, so let's code this. Have I created two sets? Nope. Okay, cool. So let's do it for C++. So I can bring this guy here. Cool. So what I will be doing is, first I need to get the first and the last occurrence of every character in S. So I'll create two data structure. So vector of int first, so that will be of size 26. Okay, then last occurrence. Okay, then I will iterate over cool, then I will iterate over all the characters. So int I equal to 0, I less than n, I plus plus. Okay, and I will store the index s of size. Okay, then what I will say is, if I haven't encountered this character yet, so which is like first of s of I minus a. Okay, if it is still -1, so which means I haven't encountered it yet, so I'll update s of I minus a to the current index I. Okay, otherwise I will keep on not otherwise I will keep on updating the last occurrence of a. Okay, cool. Now I'll create my now I will generate the palindromes. Okay, so again I will iterate over all the characters in S. Okay, so let's create a char index because I saw like I'm using this multiple times, so let's make it let's create it once and use it again and again. A. Okay, Then I will iterate over my set of alphabets, so which is nothing than j equal to 0 to 26. Okay, cool. And now I just need to check if the first occurrence of j is less than I, and the last occurrence of j is more than I. Okay, if that's the case, then I can create a palindrome with with the jth alphabet. Okay, and using I. But before that, yeah, I need to create a count variable which is ans. But yeah, if I have already updated my answer with this palindrome, I need to stop updating my answer. So yeah, so in order to do that, I will use this data structure which is vector of int, let's call it finder, let's call it 26, vector of 26, and let's initialize them everything to false. Okay, now I'll check if my finder of, or the most descriptive logic will be if I have used the ith character or this char index as my middle character and jth character as my peripherals. Okay, if I've already used them, then continue. Otherwise, mark them like I have already used them, true, and update my answer. Like I use them and update my answer, and yeah, finally I will return my answer. Cool, all test case pass. Let's submit. Cool, we are good. But yeah, if you guys notice, like this thing is still not updating, so not sure why this is happening. Cool, so this is the code. Now let's do the same for Golang. So I'll be creating two data structures, which is first and last. So last, so I'll say a make of this int of size 26 and make of this int of size 26, and then I need to update first and last. Okay, so I'll say for I, then I need the character also in range s. Okay, I'll check. So yeah, I need to create the character index. So character index is basically like when I'm converting the character to int, so in which place, and like so a belongs to 0, z belongs to 25. So character index basically tells the index of that character in alphabet. So yeah, character index of I need to do run of c minus a, run of a. Okay, so I'll say if first of char index is -1, if I haven't encountered this characters, so I will update my first occurrence of this characters with I. Okay, otherwise I will keep on updating the last occurrence of I. Okay, cool. Then I need to get the palindrome, so I'll say ans equal to 0, and finally I will be returning ans. Okay, and yeah, then I need to create this data structure, so which is my finder. So I'll say finder is a slice of size 26. Okay, and instead of int I'll say bool. So by default everything will be initialized to false. Then but yeah, for every column I need to again initialize it. So I like this in range finder. So finder of I will be make of this bool of 26. Cool. So just like in C++, we can initialize the nested array also. So but in Golang we have to do something like this. So now I'll iterate over all the characters. So for I in this range s. Okay, then let's get the character index. Character index will be run of c minus run of a. Okay, cool. Now I will iterate over all the peripherals. So let's call it j 0 j less than 26 plus plus j plus plus. So I'll check if the first occurrence of j is less than I and the last occurrence of j is more than I. Okay, and then I have a potential palindrome, but I need to check whether I have already used it or not. So if finder of I, which basically means if I have used this current character as my middle and my jth alphabet as my peripheral, then I'll simply continue. Otherwise I will mark it like I'm using it. Okay, or I can mark it as visited, so true, and I will update my answer, and finally I will return my answer. So yeah. Okay, something is wrong. Let's check. So here I'm storing I, this is rune. Continue. Last occurrence of j is this. Interesting. So we don't have seen this gives character index, then this. Why it can happen? It can happen because this is character index, this is j, this is I. If this is the case, so this check is not happening. Let's check. Oh, I got my mistake. So yeah, the issue is here. Okay, so I'm not initializing my first and last with -1, so they are by default initialized to 0. So I need to initialize them. So I'll say for I in range of first, first I will say first of I equal to -1 and last of I equal to -1. Cool, let's guess pass. Cool, now let's do it for Rust. Okay, so here also I will create two data structures. So first, so here I will say vec of I need -1 or size 26, so all the characters will be -1, and I need a space of 26, so last is vec of -1 26. Okay, cool, and then I need to update first and last. So I'll say for I in range 0 to n. Okay, so I need to create n, the length of the string, so n equal to s dot len, and I need to convert s into bytes. So let bytes equal to s as bytes. Okay, then what I will be doing is, so why I'm converting to bytes, because I can do character level iteration, but that's like every time I need to convert this string to character data type, and then I can use indexing, which will increase my runtime complexity. So yeah, let's not do that. Cool, then I will create the character index, which is bytes of I minus the byte representation of A. Okay, and So I'll say if I haven't encountered this character yet, okay, if it is still -1, okay, or the first occurrence is still -1, then I will update my first occurrence to I, and for the last occurrence I will keep on updating the character occurrence. Cool. And then I need to create my data structure, so my visited or finder. Okay, so I'll say let finder, so I'll say vector of, so everything initialized to false of size 26, and this is of size 26. Then I need to create my answer, so which is answer of 0. Cool. And now let's iterate over the loop, like all the characters. So for I in range of 0 to n, so same thing what we did here. I'll say let char index equal to bytes of I minus the byte representation of a, so this will give me the index. Then I'll iterate over j in the range of 0 to 26. Okay, so this will be like pretty similar to what we did in C++ and Golang. So I'll check if the first occurrence of j is less than I, and the last occurrence of j is more than I. Okay, and if finder of or if I have used the ith character as my middle character and jth alphabet as my peripheral, okay, I will simply continue. Otherwise I will mark them as visited as true, and I will update my answer. Okay, yeah, in range, I think I need to take care of a couple of things. Let's see if it works, because there are some i32s and there are some yeah. Cool. So what happened? Character index. Yeah, so this guy I need to say yeah, I need to say this guy as vec of i32, and this guy I need to say vec of i32. Then I need to put this guy as usize. Cool. And yeah, this guy I need to put as usize. So what basically happened is like this here I is usize, okay, but the value, so when I initialized it, that time compiler didn't know like what's the data type for it. Okay, so it checked over all the code. Okay, it saw that we are doing a comparison with a usize. Then the compiler thought that okay, so this must be a vector of usize. Okay, but when it executed this part, okay, or like when it came to this part, okay, it checked that hey, he's doing a -1 comparison, but in usize we do not have -1. So yeah, that's why it complained here. So yeah, I will annotate it like I need i32 here. Okay, and in order to put I, which is like usize here, I need to convert into i32, sorry, i32. Cool. And then this is i32, then here I'm doing a comparison, so this guy I need to convert into i32, and yeah, this I need to convert into i32. Then I think this should do. Let's see. Let's run. Oh yeah, I haven't used this. Character. Oh yeah, this will give me some i32. I need to convert into usize as usize, and similarly here also. Cool. You're getting this. Oh yeah. Cool. Cool. So this is the code and this is the logic. So let's do a quick time complexity analysis. So if I check, so here I'm iterating over all the characters, which is like length of the string. Okay, and here I'm iterating over all the characters, but for every character I'm doing 26 more operation, which is so if I say time I can say maybe here. Okay, so time complexity wise, so we are doing a big O of length of the string, plus we are doing a big O of length of the string times 26. Okay, so more of a like we are doing a big O of length of the string times 26. Okay, now as per space complexity, okay, so we are creating first and last, okay, which is of size 26. So big O of size 26. Okay, we can say times 2, but yeah, big O of times big O of 26, then which is pretty much constant. Okay, then I'm creating this, okay, which is 26 26, which is like big O of 576. Okay, which is again constant. So yeah, so I can say like it's like big O of 576, which is counted as constant. So yeah, because I know the definite size, so it will not increase. Okay, no matter the what the length of the string. Okay, I will fix it to 576, so it's constant space complexity. So yeah, these are the time and space complexity. So cool. So if you guys learn something new, please do like and subscribe, and I hope I was able to explain you the concept. So just stay tuned to watch more videos. Bye bye.